Good morning, world. Good morning, beautifuls. Did you know that if a caterpillar, right, never changed, if he never grew wings, he'd never be a butterfly. He'd never fly. Here is a board, bunch of pens, bunch of numbers. Does it mean anything? Let's take the center one. We have four corners. We have four on the inside. Each corner possesses three. If it was the second level corner, like we mentioned in the last video on Rubik's Cube, it was the second level. They would only have two corners. One, two, one, two. But if it was the top level, it would have three. So when you're talking one, two, one, you're talking about three corners. You're talking about two corners. You're talking about three corners. But I'm talking about the first level, the second level, the third level. So what would give me one, two, one? Well, the one, two, one would be here. One in the center to two to one on level one. So that would be one, one, two, one. Otherwise, it would be 1, 3, as 13 would be the four corners. 22 would be over here. 22 would be over here. Or you can also call it 21. It's up to you. Okay, but then I would mix you all up. So how do we get the scenario to understand the setup in numbers of these corners? I'm just giving you the rationale. When we come to this, we have to understand. This is the way the pointer is. This angle over here is all owned by number 1. This angle over here is all owned by number 1. 1 and 4, right? Which would actually be 5. Here is your 5, okay? Your 1 and 4 is 1 and 4. Here, would you call it your 1 and 5? Understand this. To the north of the center is 1, 2, 3, and 1, 3 and 1, and 2. When you have 3 and 1 and 2, you have 2, 4, 6 colors and 1 color. 2, 2, 2, and 1 is 6, and 3 and 3 when it's in the top row. Okay, 3 and 3 is 6, and 6. So if you go 33, here's your 33. If this eye was open, and this way, you have 33. You also have downward motion, 1 and 1. Now this one is the spindle. This would be the center of Rubik's Cube. When you spin the center, you spin 4 around 2 stationary. This is the scenario. To understand the size of this center, it's over here. When you see this special design, do you see this design up over here? We're going to do that design a little bit better. This is the actual design we're showing you coming out and going towards. This is that Pontiac design that we always see. This is the actual image. And if you can really look properly, okay, do you see the way it bends like a tower going all the way up, going all the way up? And this one coming all the way down. 2 towers, a tower going all the way up. This would represent Brazil. Okay, so now what we're going to do is we're going to go over here. 1 goes all the way down and goes all the way up. This is the scenario. If this was the scenario in time, it would be 10:30 on the clock, or an hour and a half less, or 9 o'clock on the 24-hour clock. 9:24 says the 9th hour of the 24-hour clock. 9:12, okay, would actually be over here, because that would be the 12-hour clock, and this would be the 9. This would be 90 degrees. This would be 45 degrees. 4, 5, and 10. The hand of God, 10:30, because 10 and a half, 30, okay, is 50. In time, okay, in time, when you have 12, okay, or you have 24, this becomes 48, and then it becomes 96. The hand of time times 5, right, times 4 times 25 equals to 100. But on the regular clock, it'd be 4 times 12 is 48, or 4 times 12 is 96. The 12-hour clock and the 24-hour clock. This is 100%, and this is 100% of this calculation. We have the Venus world 7. Look how 7 goes out and comes back. 7 goes out and comes back into its own area, into 9 and up to 6, into 9 and out to 8, into 1 and out to 4. This is the way. If we do it backwards, it would be out through 5, in through 9, and into 8. It would be going the other way. So if we're looking at the swastika, we're looking, is it going into 6, or is it going into Neptune, or is it going into Saturn through the birth? If it's going in through Saturn, if it's going into Saturn through the birth, then it would be going through Uranus to get into Neptune. Neptune, the 8th planet. This one, the 6th. 8 and 6. 2 times 4, 2 plus 4. Okay. Now, if we want to run them both ways to understand, this is how the split will look. Exactly like this, where we'll get one corner. Okay. Or this is actually 16. Okay. Because everything is cut into 4. A reality of a square is this. Okay. Would this be 4 and 1? 4 corners that touch 4 corners. in which this dot touches 1, 2, 3, in which this dot touches 1, 2, 3, in which this dot touches 1, 2, 3, and this dot 1, 2, 3. Each corner touches 3 is 12, but this one is doubled up. This one is doubled up, so they become the half corner. And we run straight through. Unless we make an X here, we cannot run these lines down. Now, what am I doing? I'm just explaining how things work. In this area over here, excuse me, on a cube, if I was running opposites on a cube, and I'm comparing this to the calculator, I'll be running 1 on the phone dial, and I'll be running into 6. If I was running this, or your shin, right? This is the shin. The left shin shows 1 spirit. The right shin shows 3. But if we're working low shu, this is 4 and this is 2. 24. We just understanding the basics of where the numbers. Here is your E-world lollipop. 45-degree bend, 90-degree bend, 135-degree bend. ACE, I and O, the 9th letter, and 0 is the 15th letter, equaling to 24. 2 and 4 equals 6, and the 6th number is over here, and the 9th number is over here, and the 9th number is over here, because all you have to do is that, and you get the same number. Here is 45, passage of the sun, inside of Venus and inside of Earth, according to Lo Shu and according to numbers, right? This one is over here. It's explaining the greatest diameter is 1 to 9. In this one, the greatest diameter is 3 to 7. Why would 3 be closer to 7? Because of the bend. Because of the bend. Here we have the E world. So if I go 180, okay, 45, 9, and 1, 3, 5 is 9. Okay, in which 5 and 5 is 10, equaling to 1. 3 and 4 is 7 and 1. 171 or 1771 is the gateway. If I measure up these two, I would have 5, 4, 9 is 13, which would equal to this, which would equal to 4, and we would remain the same number. If we were adding up this one into this one, it would be 5. 9 into 3 is 12, 1 is 3, and 1, 3, 5, we end up with the same one down here. This is how the actuality of the reality of the numbers work. Here is 1 and 6. 1 and 6. See, if I would close this, right? If I would run and I close it, okay, here to here, and I close it, I go into 2, 1 to 5 to 2. That is your memory, right? We see the way it goes up and down, up and down, up and down, up and down, okay? Like the sunlight would get split. If the sun gets split and goes into here, it goes down here. Okay, the reflection of the sun. But let's not get into that. Here is your E world. The C would be this one and this one. The E, okay, would be this one over here, this one over here, this one over here. These are your 3 angles, and the 3 angles on that side, E and E. The opposition of the flip of the dice, 135 would hit 45, 180. 90 would hit 90, 135 would hit the 45 down here, 180. Okay, if it's 45, 45, it becomes 90. If it was 90 and 90, it becomes 180. If it was 135, it becomes 270, becomes 3/4, and ends up as the downward pyramid. As the pyramid, okay, into time. So this one is 1 and 6. Since this one is 1 and this one is 6, this one is 7. 7 and 6. You see, it's one flag. It's one flag out here, right? If we want, we can just go one flag out here. And we'd bring it back, right? And then if you want, we can build the star system out of this. And then you'd end up with the Star of David. And this is what would be inside that Star of David. See the way this point would move over? Starting from this point, and then this area would be the same thing over here. You just have to mirror it. So now we have the camera here. Hold on. Too much light. We have the camera here, and I'm going to show you what happens. You see, here's one. We're folding them into each other. Then we have 2. See the way that the design comes in? And then we bring them together, and that would be your Star of David. You see the way the center comes? That would be your top point. Now, if we can... hold on a second. Hold on a second. Now, if we change the camera, see the way I have to fold the camera in order to get everything in? Fold it, bring it back. Now, if we fold the camera this way, see what happens? They move apart. Whoop, I got to straighten it. There, they move into each other. There's one. And you see the way the cat just appears, the legs, the nose, the mouth. See the way the M comes in? Because the M goes down and up. These are the designs, the 2 7s, the side angle to the V. The V, the difference in the V is in the center. Okay, the right and left angles because it's on 2 separate sides. Now, I'm not really happy with this video or how it's turning out, but this is the way that it goes. So we'd have this one or we'd have this one. Now, if I would take a picture, I would probably be able to show you all the angles. I'm not really happy with this video, and I don't want to upload it, and I will write that it's not a great video. Another thing to mention, and I'm pulling this thing off, and I'm going to speed up this video, is this. 2 times 1.5 is 3. 4 times 1.5 is 6. 6 times 1.5 is 9 because it takes up 1 and 1/2 area, okay? To create the diamond, this diamond shape will show you half areas. Half into the center of this side, half split in the center in this side. The square is not the same. The square is not the same. How can I show you this? That's what this was about. See the diamond? I can put a square this way, right? See this triangle? Automatically, to create this scenario, I need 1, 2, 3, 4 areas by 2 areas in order to create this. In this one, I automatically must take up 8 to get this 1 in the center. 8 and 1. This is automatically 4 by 2 is 8 areas. This is 9 areas, if you want to understand H and I. In this area over here is the same thing. I wanted to get 1 square in the center. I automatically had to turn this on an angle to take up the minimum. This would be 2 areas. 2 areas, 1 and 2, would take up 3 maximum areas. This is the minimum. You must take up 3 in order to get this. That means in order to complete this, I need 2 sides. That means I would have and secondly, this is only using up half. So if I had 2 sides, I would end up using 1, 2, 3, and only 4 to complete this digital. This would give me the digital separation between the 2 in the same area because this area is split. Not unlike this area where I would raise it, right? I would raise this over here. And I'd end up with this, and then I'd end up with this over here. And this would be exactly perfect. You see, we get the X's over here, the X over here. And to get this in the center, I would have to, these are just what I have to do, okay, to get that in the center. And this is it. And now I have my 3 digital centers. Now the real digital comes out over here. See the hexagon that comes up between this? This is what happens when we connect everything. We get our 2 hexagons, and this becomes digital time. This is the center plateau that we live, the above and the below. This is your digital time. I can probably do it on every single one, holding 2 kids in her hand, right? This one, okay, is the same thing as this one over here, right? Which shows you this that has to be discovered, in which I'll run my line down here, run my line down here, and this has to be inside in order not to touch. Do you notice that it's almost like a beak, right? It's almost like a beak of a duck. Okay, I don't know if I should put the eyes up here or what. Anyways, this has been a long enough video. One other thing I wanted to mention, where am I? No, it's not in this. Anyways, we're going to leave it at that. 13 minutes is way too long for a video. I will upload this. Thank you very much for watching.
G. Let's begin. There's 2 ways of doing G, this way and this way. Okay, you see the way it's the angle? And they do it this way, which number 7 comes out, right? Number 7 comes out. Remember, on this 7 line, on this 7, right, there's this way, and then there's the opposite way. This way will go 4, 7, 11. This will go 7, 6, 13. 4, 7 becomes 11 through 5. Both of them are through 5, but you can also run it this way. 2 ways, and this is what makes that little star. And these numbers, if you were looking in roulette, these numbers over here, which actually, okay, seem to show up as... This is the way it actually is. So this number would be brought down to 5, and this would be 4, 7. 7 come 11. This is real. This is actually real. In the roulette wheel, it comes together as 8, 11, and then 10 and 13. This becomes 23, and this becomes 19, equaling to 42. This becomes 18. Okay, it's the same scenario on a single cube, okay, running from this. I run up, actually, let's do it here. I run straight up to the next number. Here's my center, here's my center. I run straight to my next number. Then I go from here, and I go all the way up here. And I go all the way down here, and all the way back here. This is 2, this is 5, this is 7, this is 4. If it was low shoe, this would be 9 and 5, 14. This would be 3 and 8, 11, 14, 11, 25, and represents the same number that they exchanged Earth into. Raphael, 7286, in a constellation of Pegasus. One last thing I'll add in is this. These 3 sevens are connected to this hub. The top sevens are connected to the other hub, giving suspension. 777 below, 777 above. If it was 7 and 7, they'd be talking only of 2. If they were talking only of 1 7, they would be talking of 3. 1 equals 3, and 4 equals 2. That's just the way of this design. Inside of here, okay, is a bearing that goes in. How do I know this? Because I saw the design elsewhere. Raphael, thank you for watching.